Hi there. Okay. Well, we are doing a design review of new functionality for version 13 related to biosequences. So let's dig in here. So we have this function biosequence that I'm sure doesn't represent those weird new bacteria or something we just found last week or whatever. Or maybe it does with some different coding scheme. But now what are these things indicated in red?
They're the new things.
Oh, those are the new ones. Okay. So what should I be reading here? Is there other examples to look at?
Yeah, you should be reading. Yeah, anything in red, anything marked with an F, particularly these red examples here. These are the things you should be looking at.
Okay, so we've got a bunch of new names. So here's my question. If I just want to get a list of all of these, is there a data repository entry with these, or am I scraping the documentation page?
There's a biosequences type entity with these properties also defined.
Does it say that somewhere here?
It should.
Why doesn't it say it right under the table? I think that's a convention we should start to have, that this is how you get this table. Do you understand what I'm saying?
Yeah. Yes.
Okay.
Yeah, we have various instances where this is the case.
Right. Okay. So this is stuff we already had, was these things, but again, we should. So these are accessible from some entity property. Is that correct?
That's right.
Yes.
Allowed abbreviations for DNA. What does this mean? I don't understand what this means. What does that mean?
So these are our standard abbreviations also for A and C and so forth. And sometimes users will have sequences in these, particularly for the peptides. And so these are going to be supported as an alternate form of input.
So wait,
remember Emerald said they are easier to remember than the single letters.
So wait a second. So when you hold on, in a string that has an A in it, you can say D-ado, D-ado, D-ado instead of AAA. Is that correct? Am I understanding correctly? You can substitute for the capital A.
Yeah.
You can substitute this D-ado thing.
That's right.
For a DNA sequence, yes.
Okay. But why don't we say AGC? I don't understand. I don't understand the left-hand side and the right-hand side here. I don't understand this.
The left-hand side is the canonical one that we use so far.
Okay, but then so this is, if I might say so, a wrong table. I mean, this table here. Okay.
But
so
first the line above clearly spells it out.
Accept standards abbreviations in place of sequence letters. I see. Allowed abbreviations possible. I wouldn't say allowed. I said possible abbreviations include. Okay, fine. But I understand the left-hand side. I think this table is the wrong way around, right?
Yep.
Right. I mean, this is saying this is a new abbreviation which is equivalent to this. But are you also saying, where are you saying that? I mean, given that you're giving this, you might as well say what it actually is, adenosine or whatever.
Okay. There's a table of that below. I'll merge them. Yes.
Where's the table of that?
Here.
Here.
Yep.
I think we should keep them separated. The one is kind of syntax, the other one is kind of explaining something.
Then I would, well, I don't know. I think if it says A and then the alternative form, D-ado.
I see.
And then alanine, it makes sense. And I mean, that way, I mean, I would even consider.
But I think we should not mix with the meta characters.
That's fine, but then these are not meta characters. Okay, fine. The meta characters are separately up here, and then these are base pair abbreviations, which is what they are, peptide, and somewhere down here, peptide abbreviations are. Base pair abbreviations for DNA are. It's not an abbreviation for RNA, it's for base pairs, bases, right? That's what we should say.
Yeah.
And then we should say, I think these should be in the, in the kind of the typewriter, the code font, even though they're not in quotes. So should this be. And then we should say what it is. But I think it's a little bit unclear that these are both possible abbreviations. I mean, I think there's an argument that this could say A, comma, ADO, and then on the right-hand side, whatever the thing is, alanine, whatever. Am I making sense?
Mm-hmm.
I would keep them in different columns.
Okay, well, so long as then how are we going to make it clear that this is something you can type in? It's be helped by the font of the thing, perhaps. Okay, all right. So anyway, so these are, okay, so now the following bonds, the style, okay, can additionally be connected through given, what does that mean? What does that mean?
You normally have a sequence, and the elements of the sequence are connected to it rather by a strong covalent bond. But then you can take some non-local one, include them together with weaker bonds.
I understand, but what does that actually look like syntactically?
There's a third argument which lists from, where, how.
Well, then why don't you give that pattern here before you go in and say disulfur bonds? Where is that pattern specified?
Go down. You had it on the screen.
It was here, right?
Yeah.
Okay, so before you go, okay, I think that you should remind people here what the signature is, what the form of the thing with bonds is. And then here, if this is, I don't understand what this is. This is specifically, is this what you type? Or
what is possible?
What's that?
What is possible?
Possible. So for example, a disulfide bridge can only connect one cysteine residue with another. You can't use it for those other two kinds. You can connect.
Yeah, but what do you actually type? Tell me what you actually type.
Go down and look at the examples.
Where?
It'll be underneath the sequences from entities. There will be a bond section. Okay, there we go. Sequence of the bonds at the bottom.
Okay, you have got to show that in. Okay, this was utterly obscure. Utterly obscure. And what you're saying is, what you're defining there is which possible.
But this is what the usage method pretty clearly spells out, in my opinion.
Okay, by the time you've had a detailed section that's that long, you've got to repeat something.
Okay.
You can't expect people to understand without that. And here, I mean, they'll mostly just look at the example, but what you're saying here is that the 1,4 here, you should say in biosequence, blah, 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 the indices 1,4 must correspond to blah, 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 blah. You see what I'm saying? Because those 1 and 4 must refer to a C, a T, or whatever it is, and not to something else, correct?
Must maybe is not quite the right word in the do.
Well, but if okay, what possible, the 1 and the 4, that means the A and the T are connected by a multi-hydrogen bond. Is that correct?
Right.
That's right.
Okay. Okay, so, but if I chose to connect those two C's, if I said bond 2,3 multi-hydrogen, that would not be a possible chemical thing. Is that correct?
That could work. I mean, it would be an unconventional multi-hydrogen bond.
Okay, but so what is the statement that you're making about what works and what doesn't work?
Right. So in the above, the disulfide and the other one, those ones are constrained.
Okay, well, so fine. If I type disulfide there, I want to know, what does it do if I tell it to make a disulfide bond between two things which can't have a disulfide bond between them?
It will fail to evaluate and will not be true from Biosequence Q.
Okay, but so it will give a message, presumably. Tell me it gives a message, right? It gives a message. It needs to give a message.
It will give a message if it does not
give a
now.
message.
It will.
Right. Otherwise, it's utterly obscure.
Yeah.
Okay. All right. So let's go back up here to what you're saying. Okay. This is hopelessly obscure. Hopelessly obscure. First of all, you say in, and then give the signature for biosequence with a bond thing. In this, the following constraints, there are the following constraints on the, whatever you call them, B sub I or something, which are the bond indices, so to speak, the indices there. Am I making sense?
Yes.
Which is the line after the green bar.
I'm sorry, the line?
Like there's a we could instead, and then the next one. Unspecified in the form. Connect this with this.
Connect the chemicals corresponding to the string positions. I and J, those should be italic.
Yeah.
Through a bond. We usually say have the specified type when the word is actually typed, but bond specified. Okay. First of all, you should say in and then give the overall form. But so, and I don't know why these so funny kind of typewriter characters here. Should there? I mean, this just means C can connect to C, U to U, etc. Right?
Yeah,
that's right.
And so you should say in here the IJ. Okay, I mean, you've got to say in this form, given this, these are the constraints on what the I and J can refer to in the actual biosequence, right?
Okay, so basically change the order of the cells.
That's what I'm thinking, yes.
Okay.
Yep. I mean,
okay.
Yeah.
And don't use two-way rule in that table. It'll be very confusing.
That was my suggestion. I take responsibility.
Well, okay, but if you're going to use it, just don't use it as a typewriter thing. Use it with arrows. Okay, I would think this should be much higher up. I mean, it's obvious to anybody who does this for a living, but to people who don't, this kind of explains roughly what's going on. Maybe. I mean, otherwise, and each one of these, as I said, should have something underneath it that says this, in parens probably, this table is available as.
Yep.
Get what I'm saying?
Yep.
Okay.
And in fact, we should be doing that elsewhere in documentation for other things too. Okay, so what functionality? So this is, okay, I want to see the bioplot stuff because that's going to be much more colorful. Okay. Okay, so can I run this?
Be able to, yeah.
Okay, I don't understand this. Don't do it this way. Biosequence plot a biosequence. Don't define a variable just for amusement value. There's no reason to do that. Please don't do that. I think we've been through this like 18 times before. Do you understand?
Yeah,
I understand.
Why were you doing it that way? What was the point? I just don't understand. Was there a reason you did that or not?
No particular reason. I'll fix it.
You do say that in a lot of live streams, but I don't know if it's a lot with John and Michael in them.
No. I definitely have heard it. I do it myself a lot. That's why I sometimes oversee it. I find it much more natural. First define a thing and then do things with it.
Well, it
but I
depends if you're
understand
gonna do
that the
more than
first
one thing.
example is a different scenario.
Yeah,
I mean,
it's
when you just do
hopelessly
one
different.
thing, though, it's a little weird.
It's more than a little weird. Okay, so now we're going to try this. Put that in there as it should be. Okay, so now, okay, why does it have a little wiggle woggle at the beginning? Why isn't it just straight?
Because we use graph embedding, existing graph embeddings.
Okay, really, is that the right thing to do? Why isn't it just a straight line when it's DNA?
Okay, we could have a special case for this, but for more general, we would have to re-implement embeddings.
No, I understand, but okay. So look, if I say I'm going to make this a crab, don't they have just A and T? I can't remember. If I just say biosequence plot with just the letters, will it work or not?
Won't.
It will not.
No.
Okay. Does it give a sentient error message?
No, it probably just doesn't evaluate.
Okay, so this is a amusing but unuseful. What the heck happened there?
You can mouse over.
Position 17. Okay, but what's that bond there? Why is there a great big bond in the case here? Why is it gray here and small and great big here?
We noticed this earlier, that's a bug.
Okay. And if this is a graph, why am I not?
No, it's not a graph. It explicitly says the result is a graphics.
Okay.
It uses the embedding of graphs to get a layout.
Okay. Okay. All right. So here, this is getting very colorful, but what's it doing here? Okay. So this is a hybrid strand. Most of the time, okay. So for example, if I do, that's lovely. If I do, what if I do sequence alignment? Is there anything useful I'll get from that?
No, not for this case, no.
And we don't yet have visualization for sequence alignment. Is that true?
There's a WFR for it, but not built in.
Okay. That seems like the thing people, I mean, these pictures, other than for small cases where they're sort of useful for textbook purposes, these are not particularly useful for actual presentation, are they? Or am I
No,
missing
I
something?
disagree.
Okay.
The so-called airport plots for RNA are very popular.
Okay. All right. Okay. So let me pick a piece of RNA. So let's say I let me RNAify this. Okay, what happened here? Is that useful, or is that, I mean, doesn't the RNA, doesn't it curl up in a well-known way?
No.
What are the, okay.
No. There are gargantuous amounts of possible curl-ups. And Björn is working on a WFR to compute them. So now you would have to add secondary bonds, and then you get the plot of the one specified.
I see. Okay. And by the way, as Dan is pointing out on the live stream, that arrowhead looks really weird.
Yes, it's still in discussion with design, not yet finished.
Okay. All right. Okay. And so, in terms of the 3', 5' arrow E, there's a well-defined direction, which everybody understands for DNA, right? Yeah, that's just saying. Yeah. Okay. Well, that looks lovely, and this is done with graph embedding, you're saying.
That's right.
Okay. And are there, how would somebody typically get an ornate, multi-stranded, etc. thing?
There's a notation that we'll be supporting for kind of how these groups fold in on each other. There's an example of that in the neat examples section a bit.
Sorry, I don't understand.
I guess, yeah. So there's a notation with brackets and which kind of unpack into forms like that join like this.
Wait a minute. So it's like a smiles-like thing for the string here. Is that correct?
That's right.
It's two strings. Yeah.
Yeah. So you have a string mentioning the main components, and then the so-called dot bracket notation depicts the bonding.
And so what's our format for representing that?
No, we evaluated to the list of explicit bonds.
Okay, but what's the input format? Is it a single string or is it two strings or is it a string with an extra string tacked on at the end?
A string for the sequence and then a string for the bonds.
So
Yeah,
two strings in a list,
strings.
is that right?
That's right.
No,
Yes.
yeah.
But is that consistent with what else we're doing?
No, sorry. I would say it should be like we have biosequence of type, comma, and then there should be string 1, string 2. And then string 2 represents the bonds, which evaluates to the list of bonds. I mean, this we can discuss if there's an additional curly list around or not.
And this will not be in this version, so.
No, I think
You can make
John
it?
was hopeful potentially.
Okay.
So wait a minute. So just let me understand. There is an additional notation which is positionally related to the first string, yes or no?
The second string.
No, this string here.
Oh, this one, yes.
Yes.
It is positionally related to that, and it has a
That's
bunch of parentheses in it.
Yeah.
Yep.
And
Yes.
so why is it that, so it is a secondary overlay on that string. It's another thing full of parens. Is that correct? It doesn't have numbers in it. It has positional parentheses. Is that correct?
Yes.
What does it look like?
Yes.
Can you give me an example?
There is one in one of the other notebooks as in a comment to be done.
Which one?
John, which one?
Biosequence. I think it was in Biosequence.
It's in the bond section of the examples.
Where's that?
It'll be in right there. It's the
Yeah.
second one in.
Oh, yeah. Okay. So it's this creature here.
That's right.
Yes, that bracket.
Okay. So you're proposing here a third argument to biosequence.
No, the same one as the explicit bonds,
Oh, I see. I see.
because it
I
represents
see.
the bonds.
I
it's
get
just
it. I
not
get it. That
evaluated
makes
yet.
perfect sense. Yeah, that's fine.
But probably a two argument with a list around should do the same.
Really?
Cannot do much harm. I mean, because
Are you
obviously,
sure? Okay.
no, I mean, this cannot be a hybrid strand, this list of parents.
Okay.
So, but hold on. I mean, be careful though, right? Because the two argument form with a list of strings in the second has a meaning, right? Or is that-
Oh, you're right. You're right.
Yeah,
Yeah,
let's
I
not go
retract.
there.
I retract. Yeah, I forgot.
But if there is a list in that second argument, what third argument bond specification could there be? What is the meaning with the list and second argument?
It's a hybrid strand, so there would be hybrid strand bonds in the third argument.
Okay, but are they specifiable with the start bracket notation or not?
No, you don't necessarily use that bracket for mixtures.
Although
It's
you
usually
could,
for pure RNA, pure DNA.
although there's no ambiguity along the total length of the strand, so it would just, you know, if there was, say, a list of 4 letters followed by another list of 4 letters, and then you said, okay, here's a bond list 8 characters long, there's no trouble about what they correspond to.
Okay. All right. Next question. I mean, in all the stuff we have here with all these hybrid strandery things and so on, is it the case that we have now covered basically every configuration of DNA that people realistically generate and RNA and so on that people realistically generate in the lab?
My impression is, yeah, we're doing pretty well. Certainly our collaborators have looked that over, and we're covering what they cover.
Okay, so Jan must correct me just what I read as a layman. It should cover a fair fraction of what is still a sequence, meaning a linear arrangement. But people do things where they branch and are no longer a sequence.
Yeah, so we don't have the branching stuff yet. That's way far away. But the sequential stuff that mostly occur, what people see in nature, those are supported.
But in nature, DNA does not branch. Is that correct? Or has some weird...
Except there are bacteria with weird RNA motifs. But we're not doing that for now.
Okay. 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 All right. So what does this do when you just feed it things it doesn't like to eat? I mean, all these things here. If I give this,
Hopefully it's ill.
yeah, okay. I think it should give a message.
Okay.
Okay.
And in something like this, if I take a thing like this, whatever this is, and I say biosequence log.
So Stephen, going back. So maybe for an explicit string, but not
Yeah.
say for a symbol.
I agree.
Okay, good. Just making sure.
Okay, all right. So there's a magnificent object. Okay, now I'm going to just make a change here. Oh, it did something. Okay. So, I mean, I can just go with wild abandon and turn this into that. Ooh, splapperoo. Okay, that's not good enough. It's got to have some kind of message saying that that's out of range. Okay, now why did that not work? No clue. So it's got to have something that says why it didn't work. Am I making sense?
I totally agreed.
Wowee, look at that creature.
Oh boy.
He's wild. She, it, whatever. Now just feed that to your average bacterium or whatever it is. Okay, so what happened here? And why are the bonds so long? And why do the bonds look so thick compared to the actual bases?
Yeah, the thicker bonds are still primary structure. So you can see some thinner ones as well.
Okay, but why are these dots so small? This looks like
Yeah.
a bug to me.
Yeah, it is.
Yeah, that is for sure.
Can't see that. Well, it took me more than a minute to find it.
I guess the reason is that the scale return from graph embedding is too large.
Yeah.
You see, there are like pretty much in the middle. There are two bases very near together. They set the scale, and then the rest.
I'm sending this in chat just so you have the code.
Yeah, thank you.
Okay, thank you.
Oh, look at that. Now, if I were to just say graph 3D of this just for fun, it's not going to work because it's not a graph. This is very jolly. I mean, I don't know what it means. And what's happening here is very weird. I mean, is this a reasonable representation of what it physically is, or is this just a random visual representation?
It's a schematic representation, making it look like what it's supposed to look like in bacteria, for example, is a whole different kettle of fish.
My understanding is that they are overall folded in a non-trivial 3D way.
Yes.
Right. Okay. Okay, well, this is very, very nice. Okay. Okay. All right, what are those? Oh, that's just a choice.
This is a user-made one.
I see. I see. That's nice.
These are the entities that we discussed.
Other than this horrifying. Well, I guess you're doing two of them, but sigh.
But too far down, I think it's allowed.
It's below 5 folds. What is that? Okay, so this could be a molecule. So if I take this puppy, let us do it. Okay, I take that thing and I say molecule of that. And it goes crunch, crunch. Oh, fluff, 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 fluff.
Because you have metas.
What do you mean? Oh, I need to concretify these things. Yeah. Where are my metas? I don't see a meta.
In the yeah.
Where? They're concrete things. No meta. There's no meta seen.
Interesting.
I think that's the wrong error message anyway. In this case.
Oh, is the problem that it couldn't figure out the bonds?
That's a possibility. But in theory, it should ignore the bonds for molecule generation purposes, because the hydrogen bonds aren't really depicted in a molecule object.
But are these hydrogen bonds by default?
Yes, because these are nucleic acids within the biosequence.
Okay. So this just seems to be a bug.
Yes.
Yep.
Okay, but if I were to take something like this,
Yeah, that should work.
That's challenging.
I know.
Considering the size, I would.
I don't have confidence that that's going to
Yeah,
to return
exactly.
something.
I know, that's why I'm trying it. Okay. Any chance of a progress monitor?
Yes, it is. So once I learn how to do that kind of talking back and forth between the underlying code and the time, I do believe it's possible. I just don't know how.
But I mean, so there's something definite that is going on here. I mean, there's a known process that it is following.
Right. And it is iterative. I did insert the ability to abort, so it is in principle possible to call back to the top.
Flafferoo.
Right, and there is a like max attempts, an internal parameter that I set to like some smaller number so that it doesn't just keep going on and on forever.
Oh yeah, but that's a nice thing. Wow.
Mostly the problem with molecules like this is they are too to use the word floppy. They're too floppy that making 3D coordinates out of them is non-trivial. But 2D layouts, it's fine.
Right, and I mean you could write let's see, a smarter embedding routine. The 3D embedding routine that we generally use has some randomness to it. You try and
well, so the molecules.
Right. But so if you wanted to embed something like this, it might be easier to first embed the one base and then add something onto it and then iteratively build up the 3D structure rather than.
Well, okay, that's an issue for how the algorithm works for 3D structure.
I'm surprised there's not something already existing from back in the 70s to make helices out of these.
Oh, there's actually I think Jan pointed out a long time ago. There's a nice program. Just if you want to make a helix that is like geometric, you could provide it.
Well, maybe we should give that as an option for molecule plot for a case like this, right? For people who just want to curl this in a helix.
Yeah.
Yeah, I'll look into that. So it involves as you say, Bob, like an older program that you can interface with.
I'm sure they did it back in the 70s when they were first starting to look at these things on things like Evans and Sutherland equipment. But we should be able to find something and implement it in our own language, not rely on ancient Fortran.
Yes.
Right. Okay. All right, let's take a look here. All right, so we've got biosequence plot we'd had a look at, biosequence modify.
Just needs the corresponding additions to deal with the new structures.
Okay. So add a bond. Biosequence modify. Okay. All right. Move bonds inwards. What does that mean?
That means that if you have bonds on the sequence collection level, but they could be specified at at motif, one of the inner sequences, move that bond to that sequence.
There's got to be a better word than this. That's just a totally obscure thing. Move bonds inwards sounds like Bob was just commenting on their live stream about videos of the kinesin molecule walking along. That's what I move bonds inwards gives me that thought. What does it mean? It means what is the point? You have
a sequence collection. You use the 3-argument index to specify, but it could be specified by 2-argument indices.
2-argument indices. Wait a minute.
Yeah.
So give me an example. Yeah.
Like in the right upper on your right notebook, you see the hybrid, but assume it's at the lowest level, then we don't need every time to repeat the one.
Repeat which one?
The first one in the bond on the first argument. The
I am
1, 1,
utterly
2.
confused. Yeah.
The 1, 1, 2 means take the first of this, the second of this, and then the second base.
Yep.
But assume it is already in a smaller one, then move it into one of the biosequences.
Maybe if we look at an example in the Biosequence Modify page,
yeah,
better.
It's a simple example.
Move bonds inward.
We have 2 little pieces, and we specify it looking from the outside, but you could look at it from the inside.
I'm seriously confused here. Okay, so we've got this thing. It's a hybrid strand of a DNA and an RNA.
Yeah.
And this specifies that 1, 2.
This specifies the bond, say, at the outer biosequence level.
By outer, we mean that
the first
means
occurrence of the word biosequence.
Okay, but that's this 1, 2 is referring to the C and the G. Is that C and the U? Is that correct? This 1, 2 is a bond between the first letter in the DNA and the second letter in the RNA. Is that correct?
No.
No.
So
it's the first biosequence, and then the second layer, and then take the first one again and take the fourth
okay,
level.
I get it. So this is in fact, because this is only referring to a 1, it's only referring to the first biosequence.
Yeah.
It can be condensed.
Oh boy, move bonds inward. That's the most obscure. Oh my gosh.
We knew you wouldn't be a big fan of this name.
So what is it really doing? It's
So the bond is now associated with the DNA motif of that particular hybrid strand. It's not
okay, so it's dehybrid strandifying it. It's putting it on.
No, it's still a hybrid strand. Like
well,
if you look at the
overall,
output,
it's still a hybrid strand because it has both the DNA and the RNA.
Yeah.
But basically, what it's saying is, if the bonds are specifically within a single
motif, yes,
a single biosequence or something, a single sequence, then it's putting them there.
Yeah,
that's right.
Yes.
Is that the only thing it does, or can it move in 1 level and there are 2 levels altogether, or something, and 3 levels altogether?
Yeah, it can move all the different levels. It can move from sequence collection to hybrid to motif all the way down.
So one point here is that this is a purely syntactic thing. It is not changing the actual structure, right? I mean, adding a bond is absolutely changing the structure.
Yeah,
that's right.
Right, but this one here is like canonicalize. It's this
like
is
disjunctive normal form for Boolean expressions.
It's the same entities, it just changes the form.
Right. Well, I think it needs a word that makes it clear that it isn't actually changing anything. Right? So it needs to say
two innermost bond representations.
That's closer.
Could it be thought of as simplified?
No.
No.
Maybe one direction, but not the other.
Yes.
How about innermost bond representation? and then canonicalized becomes canonical bond representation or something, canonical representation or something.
Canonical representation, innermost bond representation, outermost bond representation. Those all work.
I think that's okay. And at least one doesn't think one's actually changing the molecule. Let's see. Okay. All right. Let me see. Okay. There's some questions on our live stream here. There's a question from MQ. When is this release scheduled for? We wish we knew, but we are certainly planning it solidly in this calendar year. But things can happen. Crazy things can happen, but that's our plan. In time for the Christmas season, hopefully.
And the real life representations of a lot of biosequences.
What?
Meaning,
it depends on. Yes, it depends on. Yes.
Because there was yesterday archive paper, they were predicting we will one more time see a tenfold increase in transmissivity based on various machine learning techniques applied to all existing versions before it goes away.
Interesting. Well, I have to dig back into those big immunology books that I'm reading. Let's see. Cutoff asking, can it wiggle and rotate? The answer was no, not at this time, right? I mean, this is a two-dimensional. These are all purely two-dimensional, and we don't have a way. I mean, we could be using Graph 3D to make a 3D version of this, and Biosequence plot could conceivably have a second argument that would make a nominally 3D version of this, correct?
And then maybe they'd start with a WFR.
Okay, fine.
Because the danger there would be to try and associate.
People think it's real, and it isn't real.
Yes.
Yeah.
They forget it's schematic and not the actual.
Right. I mean, this looks awfully real worldish, this thing here. And I wonder if there's a way to indicate, even in its visual form, that it is a schematic. I would say the bigger those circles are relative to the bonds, the more it looks like a schematic. And when we see something like this, that's obviously a schematic. When we see something like this, and it's got this nice little curve, that seems more like it's a physical representation.
But it's probably exactly the opposite what happens. Yeah.
What do you mean?
That in the case where, like this one, what you have on the screen, that's probably very unphysical because of this distance things. Where the other ones, the distance are maybe at least locally sensible.
Right, but I still think that you need to have the actual letters much bigger here.
Yes.
Even if that means that you have to specify things in the graph layout so that it knows to avoid and so on, so it knows to push these out, all those kinds of things.
Yes.
Okay. Suggestion that it makes a crunch noise when it's computing. The very first computer I used back in the 1970s used to make noises as it computed. It's kind of gone out of fashion, I think. Calais is asking, can we test protein chains and find out where they pass through each other? This is a protein folding. You know, there's been lots of progress with machine learning on that in recent times, including by a former employee of ours, who's now a professor at Columbia, Mohammed Al-Qurashi, who's done lots of great work on that and has been interacting with us on this stuff. And hopefully we'll have interesting things to show in that area. I mean, it has been something out of range for sort of everyday computation, but it seems like it's coming in range.
There's a nice article 3 weeks ago in Science.
There was one by Mohammed not long ago. Was that?
That's what I mean.
Yeah, right. Okay, let's see. Is the biomolecular sequences flexible enough to support non-canonical base pairs? The answer is yes. We have lovely stuff for the where do those critters live? The Hachimoji, as opposed to where do those things live? Does anybody know?
Hachimoji is actually an artificial construction. They added
Okay.
4 more bases to the original DNA.
I think it's an extended biosequence type example in here.
Okay.
Bottom.
Okay. Anyway, but we support all known reasonable
Right.
codings.
And you can roll your own.
Right. Bob was talking about microtubules. That is a different level of bio-object than what we're dealing with here. These are just molecules. I guess, well, what are microtubules? Are they single molecules? Are they like, flagella of bacteria and things that are just single protein type objects? Anybody know? That would be a Bob type of question.
I don't know. They're definitely proteinaceous. I doubt very much they're a single molecule, but they're probably composed of aggregates.
I'm just reading the polymers.
They're peptides, collection of proteins, if you will, that form the microtubules.
Yeah. Would they be possibly made up of actin or myosin or something like that?
Tubulin is the usual component of those microtubules.
That kind of would make sense. Tubulin for microtubules.
Yes, that's how they named it.
Okay, let's see. Anything else we need to look at here? Looking lovely.
Function, plot, Q. You're fine with the Q, or you want to wait?
I hate the Q, but I hate the Q. But if you think we need the Q, put in the Q. I mean, this stuff is all still experimental. I think all those kind of Q functions for testing validity should be folded into a single thing. But I mean, that's a bigger discussion. There's probably 20 of those things.
At least.
Right. So, time to make a systematic approach. Okay.
There should be everything.
Right. For people who are paying attention to live streams, we have 2 more today. My gosh. I'm living in public a lot. Well, 3:30 p.m. Eastern Time, there's a Science and Technology Q&A for kids and others. And 5 o'clock Eastern Time is a design review for trees. That is abstract trees, not biological ones. That will be for a different year. Okay. Good stuff. All right. Thanks a lot.
Thank you.